Welcome everybody to my LeetCode Weekly Contest 426 livestream. If you are here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few minutes, we'll be doing the contest live, we'll be answering questions and giving hints in the chat. So come join us every weekend for the contest. No code will ever be shared during the contest, but immediately after it ends, we're going to go through the answers for all 4 questions. So make sure you stick around. If you enjoy LeetCode contents, as usual, remember to check out the rest of my channel. I have videos on different problems as well as hardest question 4s or previous contests. And as usual, like and subscribe to stay up to date on new videos. Alright everybody, this is contest number 426. We are going to start in about 3 minutes. And as usual, just to warm up, we're going to see if we can work on the daily problem a little bit. I lost my daily problem streak a couple days ago, so I'm trying to regain it. I've also not been doing super hard in the contest recently. This is very unfortunate, but I will try. Hopefully, for both me and you guys, hopefully that we all do well this time around. Obviously, there is some luck involved, so let's see how it goes. Okay, let me see if I can quickly solve. We have about 3 minutes. Let's see if you can solve this question here. This daily problem. Given an array R of integers, check if there are 2 indices I and j such that okay. Yeah, this is pretty straightforward. This is not actually the best solution, I think. But I think for an easy problem, it doesn't matter. It's just a nested loop. Oh, you know what? It's not correct. Wait, how is this? So ARRI equals to 2 times ARJ. Oh, it's not the same. Oh, I see. So if either of them is 2 times the other. If either of them is 2 times the other. Well, this is the kind of the thing that you have to be careful. Well, I have to be careful when I'm actually doing a contest, just to make sure that things are correct. Beat 34. This nested loop is not always the best, but you know that you can do like a binary search. But as long as it passes, this is what we care about. All right, contest is about to end in 30 seconds. To also end. Oh, yeah, you're right. Hey man, Bagav, Yalagada, welcome. Hey man, try n slash 2 equals to n. Wait, n slash 2 try equals to n? What do you mean? I'm not sure what that means. Okay, well, the contest started. We're gonna dive right in. Remember, I don't show my coding screen on stream while the contest is running. So if I don't do anything on stream, it doesn't mean that I'm not doing anything. It just means I'm working on a different screen. So if you do have questions, I do monitor chat. So make sure you ask questions. I'll get to you when I can. First question. Let me just show the question. Smallest number with all set bits. You're given a positive number n. Return the smallest number x greater than or equal to n, such that the binary representation of x contains only set bits. So 111 power to a 11 to a 1111 to etc. Only set bits. So for instance, n5 7, and it's 10. Output is 15. Okay. What's the highest possible number of n? Okay, so this is pretty straightforward. Well, if we know that they only set bits, so yeah, you know what? I won't explain it right here. I'll just work on it on my own, and we'll talk about it after the stream ends. Okay, so question 1, not that difficult. Not that difficult. Question 2. I see some people coming into a chat. Welcome, welcome. If you're new to a chat, this is a contest live stream. We chat. We stream every basically every bi-weekly contest, and if there's no bi-weekly contest, we'll stream weekly contest. So once a week. If you have questions, make sure you ask them on the chat. I don't show answers on screen, so you may not see me do anything. So now we have question 2. You are given an integer array nums. This array contains n elements, where exactly n minus 2 elements are special numbers. One of the remaining 2 elements is a sum of these special numbers, and the other is outlier. Okay. n minus 2 are special numbers. Okay. One of them is the sum of these special numbers, and the other is outlier. Outlier is defined as number that is neither one of the special numbers nor the element representing the sum of these numbers. Okay, so these things can be negative. My first thought is if they're all positive, then it's very, very simple, right? Just sort them, right? The sum is going to be the largest potential outlier in nums. Okay, so basically you're saying we're going to pick 2 numbers. One, so like it's weird they call it special number. These special numbers are actually the not odd special numbers, right? All the elements, the n minus 2 elements are pretty ordinary. So these special numbers are the common ones, and then they have 2 other non-special numbers. One of them is the sum, and the other one is the outlier. So we have to pick 2 numbers. One of them is the sum, and one of them is the outlier. Let me see, how big is this array? Okay, that's not too big. Okay. So basically, yeah, I won't give away the answers here, but if you have questions, remember ask on stream. Yeah, so the idea is we basically want to find This question is actually not that. Yeah. Oh, I'm so sorry about this. Crap. I'm so sorry about this. I didn't mean to do that. Thanks, Lakshay, for letting me know. Yeah, I turned it off. So there's Sophia in the chat. Sophia is another content creator friend of mine. She's here being disruptive, so please ignore her. Yeah, so this question is actually surprisingly tricky because the numbers can have duplicates. So the question is very it's super easy if there's no duplicates, but they have duplicates, then it becomes tricky. A little bit trickier, not super tricky. Is this a singles chat room? This is not the singles chat room. This is a coding chat room. Hello, Terry Comedy. Welcome to the chat. Welcome. There are a lot of jokers here tonight. See, they're comedians poking fun. But everybody is welcome to the channel if they want to learn. So for question 2, you have to be very careful, because if you have to take care of the scenario where the special number, sum, and elements and the outlier all have the same values but distinct indices. So this is actually the tricky case that you take care of. So the special numbers, okay. And largest potential outlier in nums. What if there are no potential outliers in nums? Oh, interesting. Does this guarantee that there will always be a potential outlier based on the math? Okay. Okay, I see some people have joined the chat. If you just got here, welcome. If you have questions, ask in the channel. You won't see what I'm doing because that doesn't mean I'm not doing anything. It just means I'm coding off screen. Okay, let me see. If the special number and the sum. Okay, I got the... I want to add my own test case here. Okay, cool. Interesting. So I'm seeing a test case that is really interesting. That doesn't seem to be correct. Let me read the question more carefully. So we basically have n minus 2 special numbers, and the other one is the outlier. One of these is a sum, and one of these is the outlier. Special numbers, sum, and outliers. Oh, interesting. Okay. Okay, so question 3. Okay, that was just a small bug I had with question 2. Put test case in the chat, please. Yeah, sure, I can put the test cases. Let me see if this works. Yeah, I can put test cases in the chat. I can't review the answers though. Let me see if I still have my old test case. Oh no, I don't have it anymore. The one I failed? Yeah, WebSlick. Let me try to see if I can find it. Yeah, I don't have it anymore, unfortunately. But that one is just it's like an off by 1 bug because I did integer division rather than regular division. So I don't think you had the same issue as me. That's just a very unlucky bug. So question 3 and 4 have the same name. So normally what I do when I see this kind of stuff is I read both of them and try to see if they're identical problems. If they're identical problems, if they're identical problems, I'll try to solve the harder one and hope that that's enough to solve both. But we'll see whether they're identical problems. So question 3. There exist 2 undirected trees with n and m nodes with distinct labels in range 0 to n minus 1 and 0 to n minus 1 respectively. That sounds the same for question 4. You're given 2D arrays edges. Okay. So basically you have two graphs. Okay, 2 graphs plus an integer k. So node u is target to node v. So this is kind of a directed graph. The number of edges on the path from u to v is less than or equal to k. Note, a node is always a target to itself. You return, okay, node u is a target to v. Is target to node v. So it's like backwards. V goes to u. Node always targets itself. And return an array of n integers answer where n is maximum possible number of nodes. Node target to node I. Of the first tree, if you have to connect one node from first tree to another node in second tree. Okay, so let's try and see the example because this is very confusing to me. So example 1. Let me just draw on this. We have 2 trees here. We have tree 1 and then we have tree 2. Hey, problematic one, good job. Which one do you solve? Hints for 2. Okay, I'll come back to 2 in a bit. Let me finish explaining 3 first. So, tree 1 and tree 2. Okay, these are fairly complicated trees. And then you have, these are the edges. So k equals to 2. And the output is 97988. So let's see what we're doing here. So for k equals to 0, connect node 0. For I equals to 0, connect node 0 from the first tree. Connect node 0 from first tree. So basically, we're connecting nodes from the first tree to the second tree. Because the first tree is of size n, and the array is of size n. Okay, so we're connecting. We're connecting nodes from the first tree to the second tree. Let's see what else is going on here. So we're gonna say 0, 1, 2, 3, 4. When I is 0, connect node 0 from first tree to node 0 from second tree. Okay. And then what happens? You have 9. Okay, maximum number of nodes target to I of the first tree. So these are directed. These nodes are directed. These are edges, even though they are not shown to be directed, they are actually directed. So let's put in the directions. So we're 0, 1, 0, 2, 2, 3, and 2, 4. Hey. Hi. And then for tree number 2, we have 0, 1. 0, 1, this way. 0, 2. Yeah, sorry guys, I'm gonna get back to you in a bit. Is the answer 3? I know the answer was 3. Yeah, I'll get back to question 2 in a bit. Let me finish question 3 first. Let me finish explaining question 3. Because question 3 is kind of a confusing thing. 72714 45 45 and 46. So I think what's happening is that when you connect this 0 from the first tree to node 0 from the second tree, you get 1, 2, 3, 4, 5, 6, 7, 8, 9. So you get 9. You're able to traverse 9 nodes. Okay, so basically it's a reachability problem. So okay, cool. So we're basically calculating reachability in the combined graph.
I'm swatching.
Yeah. Okay. So let's see what happens when I equals to 1. When I equals to 1, here we're connecting I from 0. Okay, so it goes back to 0 again because 0 here is the root of the node. And 0 is able to connect to all other nodes. So there's really no reason why you connect to...
Hi. I'm so sorry, guys.
Yeah, I'm sorry that
I'm sensing a presence.
I have some friends.
He told us we could stop in, but then it looked so serious when we were watching the stream. We don't know how serious it is.
I have some friends over, guys. So feel free. They're very excited to join the stream. Yeah. Yes.
Oh look, Rish thinks we're funny. Hi, Rish.
I echo your sentiment, Rish. So just imagine that.
Imagine there's nodes, tons of nodes.
All right. Thanks, guys. I gotta get back to this.
Okay.
Okay. So for when I equals to 2, when I equals to connect 2 to node 4, why are we connecting to node 4 though? If we're trying to maximize, this is the part I don't quite get. If we're trying to maximize the number of node target to I of the first tree, if you connect one node to... Why are we connecting it to node 4? Why are we connecting to node 4? This is something I don't quite understand. Okay, you know what? Let me sit on this a little bit. I see a request for question 2. Question 2. I'm gonna go back to question 2. And let's talk about question 2 a little bit. Because I'm totally confused by question 3, guys. I have no idea what it's trying to do. Sorry again about the noise. There's some guests in my apartment. Just a little bit, not too much. It's okay. Just a little bit, Sophia. It's fine. Yeah. So let's come back to question 2. So question 2 is identify the largest outlier in an array. All right. So let's look at an example. 2, 3, 5, 10. Okay. So basically what we're doing is we're going to pick two things. We have an outlier and we have a sum. So we pick one thing called a sum and we pick one thing called an outlier. They have to be two different things. And everything else is special. And the specials added up must be the same as sum. Okay? So basically you're picking two numbers. You're saying that the first number, I'm going to ignore this guy. Second number should be the sum of all the numbers not picked at either the two numbers. So how do you do this? Well, there's one way you can do it. Yeah, so for instance, in here, if you pick this as an outlier and this as a sum, then these two are your specials. 2 plus 3 equals to 5. So these two added up give you the sum, and 10 will be an outlier. So there can be many possible outliers, but you have to find the largest outlier. So one way to do this is just binary. It's a two-dimensional. It's a nested for loop, right? You just try all the possible sums and all the possible outs. But there's a catch here. The catch. The catch is that you don't want to be summing these specials manually. What you want to do is you want to have a total of some kind. So the total is the sum of all the numbers in the array. Right? And if you think about total as the sum of all the array, what are the relationships between out, sum, and special? Well, sum equals the sum of special. So out plus sum times 2 equals total. Right? This is a very important relationship to get. Out plus sum times 2 equals total. In other words, if you find out what the total is, which is the sum of all your numbers, 2 plus 3 plus 5 plus 10, you take the largest, you try the largest number first. So you take total minus 10, and then you divide by 2, and you want to check if that number appears in one of these numbers, right? So that's the general strategy. The general idea is you have a total, which is sum of all the numbers in the array. You want to try all the outs in turn. You subtract out from total, and you divide the remaining by 2. And you see whether you can find somebody who is equal to that. Yeah, so you can use some kind of hash map. You can use kind of set. Do that quickly in Python. What's the code for first one? Yeah, so we don't in this channel. So we don't share code in this channel because that's against the contest rules. But you stick around to after contest. We'll talk about all 4 questions. So make sure you stick around.
Yeah, don't cheat. We're against that on this channel.
No cheating.
No cheating. That's right. All right. Let me come back to question 3 because I'm just as stumped as you guys. Let me know in the chat. How are you guys doing? Let me... Oh, God. I gotta... Yeah, I'm sorry, guys. Just give me a second. Just give me a second.
Oh, no. Too much. Where'd it come out? Comments here? No. We have to give it a break, at least 5 minutes between bits.
Because it's very serious and they're studying coding.
Okay.
All right.
But we got an LOL.
Can we say like? Wait, are you on the camera now?
Do we need to sort array in question 2? That's a good question. So it will be a good idea because in question 2, you're trying to find the highest outlier. You got a fast way to detect whether a number is a candidate outlier, right? So if you want to do that, you start from largest number first. Check, is this a possible outlier? If it is, That's your answer. If it isn't, then you move on. Sorry, let me check if the sound is okay. Okay. I think the sound is okay. If so, my place is a little bit noisy right now. I apologize for that. If you guys hear a lot of loud sounds, I would try to temp that down a little bit. I apologize for that. It's not really within my control at this point. Yeah. But it's just for this week. I promise this will not happen again. Okay, so I want to see. So I've looked at question 3. I want to see if question 4 is the same. And to be honest, I'm going to be very frank with you guys. I don't understand what is question 3. I want to see if question 3, it looks the same. No, it's different. Because with the same input, they actually give you different answers. And for question 4 has no K. Yeah, so let's try to focus our attention on question 3. I'm going to focus on my attention on question 3. Okay, so there exists 2 undirected trees. Okay, so node is target to node V. If node U is target to node V, if the edges on the path is less than or equal to K. Okay, so they can, like a range of 2. So it's basically if you can reach this guy. Oh, okay, I get it. Okay, so K is 2. So basically it's saying if you can reach this guy at a range of 2. And these are all directed, I think. Oh, they're not directed. They're not directed. So if I connect 0 and 0, I see. I understand the question now. So I connect to 0 and 0. Then my range of this source node will be this one, this one, this one. Because K equals 2, right? K equals 2, I can take 2 steps. So this one, this one, this one, this one, this one, and this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait, why is it not 11? It's 9. Oh, sorry. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this will be like the range. So K is kind of the range, right? If you connect this at here, what is your range? Probably what you want to do is to connect to the guy who's most in the middle. I think that's very interesting. I would assume that the best strategy is always connect to the guy in the middle. Why would you not connect to one? For node 2, so if node 2, I'm connecting to node 4 from the second tree. 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is 9. Why don't I connect? Okay, this is interesting. Why don't I just connect to node 0? Why do I want to connect to node 0 here? Because node 0, 1, 2, 3, 4. 3, 4. Okay. So basically, I want to connect to the guy who has the most neighbors, right? Because there's only one connection between the 2 trees. So basically what I need to do is to find out how many neighbors I have within K range for each of these nodes. And I just connect to the guy with the most neighbors. Why would I ever want to do something different? Let me see what happens. Every node connects to I with any node of the second tree. So K equals to 1. Okay. Okay, I don't understand this. Why do I connect this to... Oh, because k equals to 1. So if k equals to 1, it doesn't matter who you connect to, because you only get one bonus node. Okay, so it looks like, the way I'm reading this question 3, the way I'm reading question 3 is that it almost doesn't matter. Like, everybody will connect to the same guy. You just connect to the strongest guy. For each graph, you find out who is the sort of central node, the most well-connected node with the maximum number of neighbors within range 2. And then you always connect to that guy. Yeah? So, in fact, what you have to do is to calculate the maximum number of everybody's neighbors within range 2 for yourself. Yeah. Yeah. Okay. So I think that is a pretty straightforward. Okay. So that's a pretty straightforward strategy. Yeah. For those of you who just joined me, welcome to the channel. I normally what I do is I explain the question and my thought processes on one screen, but I actually code on different screens. So you're not gonna see my code, but if you have questions, feel free to ask. I hope the explanation for question 2 was sufficient for you, WebSleek. If it's not enough, let me know. So it looks like what we want to do is to find the most well-connected people. I probably would write a function to do that because I'm going to do it twice. Once for edges 1 and once for edges 2. So as usual, what I probably want to do is to turn the edge list into some kind of explain the formula. Yeah, sure. So explain the formula. Basically, you need to out of the list, you need to pick 2 things: a sum and an out, the outlier. So outlier, a sum, and a bunch of specials, right? A bunch of special numbers. The last 2 numbers, one is a sum and one is an out. So what's the and then what happens is then you have a total. So what's the relationship between the total and these things? Well, if you add them up, all the special numbers added up plus all the sum added up plus the outlier value is going to be total. And you know that this sum equals to all the special numbers added up. So what's the value of, right? Total is special plus sum. Special, so sum of special plus sum plus outlier. So sum is equal to the summation of the outliers, all of them added up together. So that just means that total minus out equals 2 times sum. This is math, right? This special add up is sum, this out is out. So how do you find if somebody is outlier? Well, take total minus out. You look at a number like this 10, I want to know if this is a candidate for outlier. I take total minus out, and then see if the sum appears there. That's the basic idea. I don't want to give any more than that. I feel like I've already given a lot of information here. I will be careful about giving away too much information on stream because ultimately this is a contest. If you still need more help, definitely stay behind after the contest ends. We'll talk about the questions in detail. So for you, yeah. Yeah, so this is going to be some kind of edge list. Yeah. So if folks need me to explain question 3 again, I can do it. Right now, I'm very focused on solving question 3. I don't think I'll be able to solve question 4 today, but I want to make damn sure that I solve question 3. Unlike the last couple of weeks have been a bit of a disaster, I'll be admit. So I want to create some kind of adjacency, some kind of lookup adjacency matrix, and the adjacency matrix basically says, in this some kind of adjacency matrix. Okay, so essentially you want to find what is reachable. Did it say what n is? 0 n minus 1 nodes of length n and m respectively. explain the formula. This edge like the last one. Minus 180, minus 180. Is this edge like the last one? I don't think... Yeah, I don't think last element one, the edge case. Yeah, so so in this case, the outlier is 517, right? Because if the outlier is 517, one of the other two will be the sum. So this will be the outlier. 108. 1 is the sum, and then this is the special. Yeah, so you have to be careful about this because the special can, sorry, not the special, the sum can also be one of the specials. That's the part that's tricky. In fact, the outlier can also be one of the specials. The outlier can also be a sum. So you have to do a little bit thinking there to see what's the best way to do this. Let me see. Yeah, so folks who just joined, feel free to hang out in the chat room. Feel free to ask questions. Question 3 is kind of interesting. Question 3 basically is a graph problem. What you want to do is you want to find how many of these guys have neighbors within K range. So I'm not going to go through that part yet because that's part of the contest. You have to work on it yourself. I will go through the answers at the end of the contest. So make sure you stick around. Okay, I'm a little annoyed that they don't give us N. Oh, they do give us N. So let me see. Stick labels in. Yeah, so they kind of give us N. They kind of give us N. So N is basically the largest label in the tree plus 1. So the reason why this is kind of a little bit sketchy is because there's no guarantee that the nodes are all connected. I don't think it says anywhere that the graph has to be fully connected. Second one code, please. Yeah, B is so easy. Yeah, different strokes for different folks. Some people find it easy, some people find it hard. And it already depends on where you are in your journey. So try not to compare yourself with others. If you're ahead, that's fantastic. But if you're behind, it's totally cool. Okay, so what we want to do is, okay, so in question 2 I've basically found the number of neighbors within k range, and also I have to find neighbors within k minus 1 range for 2, because it takes one step. Which one? I plus alright, let's hope for the best. Nope. Nope, doesn't work. Let's see what happened here. Second 2 code, please. We don't share code here, but we will go through answers after contest. Yeah, sorry, we don't share code while the contest is running, but after the contest ends, we'll go through all the code. So don't worry, hang in there. If you need help, you can go back to the video a little bit, and I do talk about the question 2. After, if you still need help after I'm done with question 3, I will come back and talk about question 2 again. But I'm trying to solve question 3 now. Okay. Okay, so something is interesting. So I feel like I might have been misunderstanding this question after all. This is such a complicated question. So it says here, when I is 2, connect node 2 to node 4. And then k equals 2, right? Okay, no, this is correct. So 4, 1, 2, 1, 2, yeah. Okay, no, this is correct. Okay, so 0. So basically,
Right, every time I'm doing this, but some of you were right. But I was right and some of them look bad too. It's fine, I wasn't judging anyone. I was just looking and making notes in my head and on TikTok because I was thinking about doing a purchase. Smart consumerism, okay? But these look good. Some of you were right. Great.
okay, interesting.
You have 8,000 followers?
Yeah, I'm really close to that 10,000 and I'm start making money.
Who are they?
Ah, interesting. So let's see. Okay, cool. So I think this is correct. 9686. Interesting. So 0 should include 0, 1, 2. Okay. I got a bug somewhere. So I think question 2, getting a wrong answer on 61 for question 2. Okay, let me see what the correct answer is. What's your answer? What do you Yeah, I can't run it on mine because so I got minus 35 as the outlier. Minus 35 is outlier. I think there's another answer. So I think what you're doing, I think, I'm not sure, but I think what you're doing wrong. Yeah, I think what you're doing wrong is there's only 113. You need to make sure there's only 113. If you use the 13 for an outlier, you cannot use 13 for the sum. Does that make sense? So if you use 13 for an outlier, you cannot use 13 for sum. I think that's the stance. That's the reason. Okay. Okay, I'm still trying to solve my eight five 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 979 97988. So it's 855. Huh, interesting. Okay, so if k equals 1, okay. I think I got question 2. Sorry, I think I got question 3. Let's run it and see how it goes. Please. Oh, damn it. I think I might have a timeout in question 3. That is very disappointing. Oh, I have a wrong answer, not a timeout. Okay. So edges 1, 0, 1. Okay. K equals 0. Output is... Okay. Okay, let's see if this works. Hope I don't get a timeout. Okay, let's see what people are doing. Hint for question 2? Yeah. So hint for question 2, let me come back. Yeah. So hint for question 2 is very simple. There's a mathematical formula that governs the relationship between the special numbers, the sum number, and the outlier. So if you add all the numbers up in the array to get total, total equals to all the special numbers added together, the sum number, and the plus the outlier. So if you want to see if an outlier, a number is eligible to become an outlier, you want tests. Can this 10 here become outlier? All you have to do is to take the total minus 10. That will give you the sum of these two things. Divide that by 2. So total here is 20, right? Minus 10, you get 10. Divide that by 2, that's 5. And then you check 2, 3, and 5. Is there somebody who is 5? If there is somebody who is exactly 5, then that number can be your sum number. And 10 will be an outlier. So 10 will be a good outlier if total minus that outlier divided by 2 appears in the array. So that's the basic idea. I'm going to leave the specifics to you. Okay, I got a time limit exceeded. That's might be because I have a lot of print statements. Let me see if I can get this. I really hate the time limit exceeded because it's one of those very pernicious problems. Yeah. Let me see if... Let me see if this works. Okay, I need to get rid of all my print statements because I added a lot of print statements. Okay. Yeah, I don't see how this can be. This is a little bit not fun for me because I don't see how this can be. Is this this is the asked by Amazon recently question 2. Really? It's asked by Amazon recently. Yeah, I wonder if they shuffle their questions around. So question 3, I'm getting a TLE. I'm trying to make it faster. I don't know how to make it faster. I think there's a trick around like K being if K is small, then you can be a bit fast. Okay, let me try again. Edges. Hmm. All right, let's see if this works again. I made it a little bit faster, but I feel like I'm not solving the actual problem here. So I made it faster by taking some shortcuts. Okay, sorry. Let's come back here. Suresh Chirani, explain question 3. Yeah. Yeah, 3 out of 4. Great job, guys. So for question 3, basically is a graph problem. It's a graph problem, right? The idea is you're given a number k. You're given a number k here. And what you want to do is to, for each node here, you want to find out, you want to connect this node with one other node here. Let's say 2, you connect to 4. And you want to find out, within k range, what is your large, what is the maximum number of neighbors you have, but when with the word neighbor be defined as being nodes within k range. So for instance, in 2, when k equals let's say let's pick a different one. So let's say you are 4, and you connect that with node 4 over here, right? K equals to 2. Where can you go? 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So you have 1, 2, 3, 4, 5, 6, 7, 8. So 0, 1, 2, 3, 4. Yeah, this one over here. That's why this is 8. Right? So basically for each node here, you want to pick a node on the second graph to connect yourself to, so that you're the maximum number of nodes within k range. Now note that traveling this extra edge here, traveling to the other graph takes up one move. So here basically you find everybody within 2 range. This you find basically everybody within 1 range. Huh, interesting. Yeah, I don't know how to make my graph this guy even faster. I feel like I've gone the max of as fast as I can. How do I make this faster? Yeah. So if you think about it this way, basically there's two graph problem. So you basically, the idea is, who do you want to connect to, right? You think about it, who do you want to connect to? You want to have as many neighbors as possible. Well, you're just going to connect to the guy with a lot of neighbors. So for each of these nodes, you want to calculate the sort of people within k range. In this case, it's 2. So you want to calculate how many people you have within k range. This is 1, 2, 3, 4. So this is 4. This is over 4. This is only 3. And this guy, 2, 3, 4. These guys have 5. These guys have 5 neighbors within 2 range. And then you can look for these guys, how many do they have within k minus 1 range? Because don't forget, it takes one move to get from here to here. So you want to see which node, who should you connect to? Well, everybody should basically connect to the same node, right? Even though here they said, some they connect to node 0, some will connect node 4. Actually, node 0 and node 4 both have the same number of maximum nodes. Maximum children. Sorry, maximum, what do you call that? Neighbors. They have maximum neighbors. Yeah, I think there might be a well-known algorithm then, yeah. Maximum neighbors. So basically, you want to calculate for this, how many nodes you have within k plus k minus 1 range, and then you connect to him. This guy has 1, 2, 3, 4, including himself. So this guy is very well connected. You want to connect to him. So 0 also has 1, 2, 3, 4. So the thing is, the truth is, this should all be 0, or this should be all in 4. It doesn't matter. You just have to connect to the most well-connected node in the second tree. Yeah. Yeah, I did third one, but somehow it gives me a TLE. And I can't figure out what the TLE is. So I got TLE for the third one. Yeah, so I don't actually know what's the reason I got TLE. I thought my algorithm is really fast. It's definitely ON algorithm in it's an ON algorithm in the size of the edges. So I'm not super sure why I got TLE. I wonder if it's because I'm creating a lot of. I wonder if it has to do with how I'm writing my my graph algorithm for finding connected edges. I wonder if I'm slow because the graph is dense. ICFAI University Jaipur. Oh, that sounds very impressive. Calculate sum that assume is outlier, solving using maths. Yeah. Yeah, basically that's what you need to do. Yeah, basically what you need to do is you find out the outlier, just solve it using math. I'm having some TLE with question 3 and I can't figure out what it is. Okay. I don't see why. I feel like my algorithm is super fast though. Why would be TLE? Unless this is really dense and I'm supposed to only look at new set. Let me see if I can like cheat a little bit. I think maybe a very dense graph. But even the dense graph should not cause any problems. Uh, yeah, sum minus nums I over 2. Yeah, that's correct. Well, sum minus nums I over 2, then you need some kind of set or some way to discover what it is. Okay, so I don't think I'm able to get question 3 down to pass the time limit. I still get TLE. I'm curious why, but I'm very confident that my solution is correct. There might be a bug that causes it to be work slower than normal. While the contest is ending, but while I have you guys here, as usual, a plug. If you enjoy this channel or if you like what I do, I would really appreciate if you like and subscribe. Just click the like button on this stream itself. It's going to help me out a lot. If you can, leave a comment on the VODs when they come out in about 30 minutes or an hour. That's going to help a lot. The contest is coming to an end. I'm going to grab some water, come back, and then we're going to go through all 4 answers for all 3 questions. I didn't get a question 4, so I'm not able to do that. We'll go through question 2 in detail because it sounds like that's what people are interested in. But give me 1 minute, and also if you haven't liked the stream yet or subscribe to the channel, if you enjoy my content, subscribe. If you don't enjoy my content, no need to subscribe. As usual, I'm here every week. I always stream the bi-weekly contest, and if there's no bi-weekly contest, I'll stream the weekly contest. I'll be back in 1 minute. I'll see you in a bit.
Are you done? Did your viewers like us? Oh, really? Just you 4? I know. Your team is big. What happened?
All right, I'm back. All right, contest has ended. I hope that you guys did well. Hopefully you did better than me. But if not, as usual, I always say this. You'll hear me say this all the time. As long as you put in the effort, and as long as you learn something, you basically win, right? Because at the end of the day, what rank you get, what rating you get, does not matter a bunch. It doesn't matter. Nobody cares what rating you got on LeetCode. But if next time you want to apply for a job, you want to do a coding interview, actually getting good at coding, essentially on the fly, is going to help you secure that well-paid job. That's what we're all gunning for, right? The actual contest rating or gaming thing does not really matter. It's just a way. It's just an excuse, really, to make yourself practice. Okay, cool. Let me read my usual script for the YouTubes. We are discussing solutions for LeetCode Weekly Contest 426. jump to specific questions using timestamps in the video description. Please check out the rest of my channel. If you enjoy LeetCode content, like and subscribe to stay up to date on new videos. Alright, so today's contest was not too difficult, I think. I did manage to do question 4, but I did manage to complete two questions. But last one, I'm pretty sure I have like the strategy for question 3, but there's some bug that prevents me from clearing the TLE. I am going to talk through the solutions for all 3 questions, and I'm going to see if I can do question 4 off stream in a separate video on a different day. So stay tuned if you're interested. Let me know in the comments, in the chat, how you guys did. I think some of you managed to do 3 questions, some of you managed to do 2. Whatever the case is, I would love to know. What was easy for you, what was hard? Talk to me in the comments. Alright, so let's begin. So question 1. Question 1. Smallest number with all bits set. You're given a positive integer n. Return the smallest number x greater or equal to n such that the binary representation of x contains only set bits. So what does the binary representation of n contain only set bit mean? Well, it means like 111 in binary is 7, for instance. 11 in binary is 3. 1111 in binary is, I think, is 15. Yeah, so all set bits means all ones. Essentially, you're looking for binary numbers whose digits are all ones. Now, which binary numbers have digits all 1? Well, if you look at them, there's a pattern. This is a very well-known pattern. If you're familiar with computer science, many of you will know this is equals to 1000 minus 1, 100 minus 1, 10000 to power 2 to minus 1, right? In binary minus 1. So basically, they are all 1 less than a power of 2. So 7 is equals to 8 minus 1, 3 is equals to 4 minus 1, 15 equals 16 minus 1. So they are all 1 less than the power of 2. So if you know this, then you save yourself a little bit of trouble. You don't actually have to do the binary conversion. All you have to do is something like the following. Let me copy the answer over. Essentially, what you want to do is to iterate over all the possible ranges. So because I is smaller equals to 1000, 12 is the largest power of, it's not going to be larger than 12. 2 to the power of 12 is going to be much larger than 1000. You can use 11. I think 11 also works, but 10 does not work. So you do 2 to the power of I minus 1. So this would be 1, and then it's going to be 3, and then it's going to be 7 and 50 and so on and forth. Check if it's larger than or equals n, return it. If not, return 0. So that's pretty straightforward for question 1. Yeah, let me read the chat real quick. Sakni Sen Sama, almost question 3. Yeah, I'm also almost question 3. I'm kind of mad. Oh my god, Nash, I'm so sorry about this. You just submitted again and was accepted the one. Yeah, you know what? I'm so mad. Are you pre-computing the value at every node at distance k in first and the... Yeah, I am pre-computing. I am pre-computing the value at... I'm doing exactly that. I think what I'm doing, the TLE, is like a low-level tactical thing. It's not the overall algorithm. Yeah, so I'm doing the same thing as you, Nash. I don't understand why. Okay, I did all somehow felt like I read question 2 somewhere before. Oh, Maddox. Maddox. Very well done, Maddox. Yeah. You did all 4. Oh my god. I'm so proud of you. Very well done. Very, very well done. Suresh Chalani, 2 to the power k minus 1. Yep, it's 2 to the power k minus 1. Okay, cool. So that's question 1. Okay, let's look at question 2. So question 2 is, I think, the one people were talking about. So question 2, let's see what it's talking about. It says here, identify the largest outlier in an array. You're given an integer nums. this integer contain n elements, exactly n minus 2 elements are special, one of the remaining 2 elements is the sum of the special, and the other one is the outlier. So there are basically 3 types of numbers in this array. Regular numbers called special, I don't know why they're called special, they're just regular as numbers. A sum number and an outlier number. Okay, so your array is very long. One of them is a sum number, and then one of them is an outlier number. Okay, so what you want to do is, you know that all these guys added up, these specials, the special added up equals to sum. Okay, the specials added up equals to sum. And then what you want to do is to find the largest outlier for whom this is possible to pick a sum such that the specials add up to sum. Okay, so for instance, 2, 3, 5, 10. If I pick this as the outlier, 2, 3, and 5, I can pick 5 as the sum. 2 plus 3, these are the specials, add up will be 5. And this 10 is a valid outlier. So there can be multiple valid outliers, and what we want to do is find the biggest valid outlier. Now, you might be thinking, okay, one strategy I can use is sort them from largest to smallest. You know, try each of them as outlier, and for each outlier, basically I go through all the possible remaining values, test each one, is it a possible sum. And what you do is you add up the rest and then you minus the sum to see whether it works. Well, that's good. That can be pretty slow. That is actually going to be pretty slow. I don't think that's going to be fast enough, because if I look down, that's probably going to be n squared, and this num sort length is 10 to the power 5. So there's actually a very fast way to test whether something is an outlier. So given a number in this array, you want a fast way to check, is this a possible outlier, right? So the way to do that is using some mathematics. First, what we want to do is compute the total of everything. So total. So the total of everything is equals to the sum of the specials plus the sum plus the outlier, right? But the sum of the special and the sum is the same number, because sum of the special equals to sum, right? So it's basically the outlier plus 2 times sum. So how does that help you? Well, this means that if you want to test if a number can be an outlier, what you want to do is to take total minus this potential candidate outlier, and then you want to divide it by 2, and you want to check, is there a number of this value? So for instance, I take 10, the total of this is 20. If I try 10, 20 minus 10 divide by 2 is 5. So I see among 2, 3, and 5, is there a number that is a sum? Yes, there is. So we're done. Okay? So that's the basic idea for how we want to do this. That's the basic idea for how we want to do this. How do we actually put this in practice? Well, it's not that hard, but can be a little bit tricky. So how do you check if something appears, if there's a value that appears in this rest of the array? Well, what you want to do is you want some kind of hash map, right? You want some kind of hash map that tells you, does this appear? Yeah, so to check if this, you just use some kind of hash map. But there's a catch though. The catch is the sum can be the same as the outlier. So you have a hash map, you need to know that the number you pick for the sum, if it's equal to the outlier, you need 2 copies of that number. 1 time for the outlier and 1 time for the sum. I think that was tripping up a lot of you. I think that's the part that's tripping up some of you. Yeah. So the code looks something like this. First, I follow it from largest to smallest. I just find the total, and then I create this thing called frequency. This is a frequency table that tells me how many times each element appears. You can use I initially use hash set. That actually does not work. I end up using a frequency table. So for each I, from largest to smallest, I start with the outlier. Largest, smallest means the moment I find a candidate outlier, I can stop. Outlier equals to this. Sum, this potential sum equals to total minus outlier divided by 2. If this sum is not in the frequency table, then I'm done. I just go on to the next one. That means it's not an outlier. If it is, then what I check is if this number appears only once, I need to check that outlier is not the same as sum. If this number appears more than once, then I can use it once for the outlier and once for the sum. I don't care. There's actually an example that does this. This guy right here. There's 1 1 1 1 1 1 1 1 1 5. 1 for the outlier and 1 for the sum. If there was only one copy of 5, I cannot use it for both. Then that guy cannot be an outlier. There's one specific test case to test for this. And I think that's why some of you didn't manage to do this. Yeah. So that's basically the answer for question 2. 1 year to placement. How do you do it? So let me read chat a little bit. Brother, how do you do it so easy? I was stuck on it for more than 1 hour and still not able to. Was only able to do the first one. Very easy. Well, brother, let me tell you this. There are people. Okay, hey, no cap. Look at these guys. They finish in six freaking minutes. In 10 minutes. Okay? Even the slow ones, they take like half an hour to finish all 4 questions. So how are they going? How can they do this? I'm struggling to finish 3 questions, and you're struggling to finish 1. So it's ultimately it's going to be a journey. It's going to be practice. A lot of it is identifying patterns. A lot of it is patterns of questions. So you look at a question, you look at you know the pattern, you sort of solve it along the path. This is also true in software engineering because a lot of software engineering is pattern recognition. Though not to the extent of these kind of competitive programming problems. Okay, so that was the second question. The third question is really, a little bit is quite interesting, but it's also really annoying. I'm going to be very honest. Okay, let's read it. What it does. Question 3: maximize the number of target nodes after connecting trees. There exist 2 undirected graphs with n and m nodes with distinct labels. Okay, you're given 2 integer array edges. They indicate there's edge between this and edges 2 indicate there's edge between this in the second tree. Okay, so what this is actually doing is that you're also given an integer k. So what this is actually doing is essentially giving you the edge list for 2 trees. As you guys will know, I personally hate edge lists. I think the stupidest, most useless data structure. I almost always automatically converted to adjacency matrix, which might have been what came back to bite me. I'm not sure yet. Okay, so node U is a target to node V if the number of edges on the path from U to V is less than or equals to K. So basically, you're defining adjacency. You're defining like neighbors. U and V, U is target to V and V is target to U if the distance between them is K or fewer. So you want to find like the set of nodes that are within this K range from U. Okay, so your job is then return a array n of integer numbers, answers. So array size n means that you go through each of the nodes in tree 1. You go through each of the nodes in tree 1. And this is a little bit non-trivial. What you want to do is when you go through each node, connect this node to one node from the first tree to one node in the second tree. And you want to find the maximum possible number of nodes that you're in range to. Okay, so let's go through an example. When I read this, I was really confused also. But let's go through an example. So in this example, k equals 2. Okay, so in H1, let's say I'm node 0. If k equals to 2, this, all of these guys are within my range. Okay, and then if I connect 0 here to this 0, 1, 2, 1, 2. Now this node and this node are also in my range. So my total number of oh sorry, one more. This 3. These 3 plus this 1. So my total number of nodes, my total number of targets, including myself, is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 for node 1, for node 0. Okay. If you're in node 1, on the left hand side, you can only your range k equals 2 is limited range, so you're only able to connect to node 0 and node 2. So these are your sort of targets in tree 1. And then if you connect it to node 0 again, you get additional targets. 1, 2, 3, 4, 5, 6, 7. So total 7 targets, including yourself. Right? So this is the basic idea here. And then you just keep going down. You just keep going down. Now, this is very interesting. So in this example, they did something tricky, right? For node equals node 1, it connects to 0. Node 2 actually connects to 4. Now look at what happens when node 2 connects to 4. When node 2 connects to 4, you get all 5 here. 6, 7, 8, 9. Okay? But, wait a second. If I take node 2 and connect to node 1, I actually also get 9. So the truth is, these things don't have to be 4. They can also connect to 0 and you can get the exact same result. Actually, what you want to do, you think about it. If you're a guy in tree 1 and you want to have the maximum number of neighbors, you want to connect to somebody who is really well connected in tree 2. Does that make sense? If you want to maximize the neighbors in your range, right? Who do you connect to? Well, connect to somebody who's already really well connected. That's the best way to do it. Yeah. That's the best way to do it. Yeah. So really, you don't have to figure out which target node to connect to. Just find how many people you have within the range, and then find the most well connected guy and connect to him. Now, when you connect somebody from tree 1 to tree 2, it costs 1 step. Like this 2 costs 1 step to connect to here. From this 0, you only have k minus 1 range. So 2 has 2 range. This guy in tree 1 has 2 range. Here, 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 here. This guy only has a range of 1. So what you want to do is for each node in tree 1, calculate how for each node number of targets in k range. And then tree 2, find the node with max targets in k minus 1 range. So basically this is what you have to do. In tree 1 you calculate targets in k range, and k2 for all nodes, and tree 2 you find the node with the maximum targets in k minus 1 range, and then everybody in k1 will take turns connecting to him. That's the idea. So for instance, in K2 in this example, the most well-connected node is node 0. Node 0 has 4. So in this example, this is 4, right? So basically just calculate targets in K range in tree 1 and all of them add 4 plus 4. You can actually see the same thing happen for the one below. In this example, because k equals to 1, when you connect, you can only connect to one person. Doesn't matter who he is, you only get a plus 1 no matter who you are. When k equals to 0, you get plus 0. Essentially, you just connect to yourself. That's why node 0 is 6, 0, 1, 2, 3, 4, 5, and plus one more, 6. That's why you can connect to any node in the second tree. So that's the basic idea. You want to calculate all the targets for tree 1 and all in k range, and all the targets for tree 2 in k minus 1 range, and find in tree 2 the most well connected node, and everybody in tree 1 just take turns connecting this guy. So that's the basic idea. Okay, so this is my code. Essentially, I did some optimizations. Let me see if there are any questions in the chat. Can I share my third solution? Yes, please. So Nash, do you have paste bin? I also do this like question. So Suresh Chalani, do you manage to do it? So it's very funny. I got TLE when I do this. I'm not sure why. I think it's like a small tactical error that I'm doing. Yeah, I don't think it's anything like big or special. It's just a small tactical error. So this is basically what I'm doing. I did some optimizations in the end because I got a TLE. I'm trying to figure out what happens. So the first thing I do is to find what is n. So n, I just find the, I don't actually have to do this. I can just say edges, because a tree, n equals to, I forgot there's a tree actually. Length of edges 1 plus 1. Length of edges 1 plus 1. Okay, and then next thing is I create a result, is the result array. If k equals to 0, everybody is just connected to themselves. Then the answer is 1 for all the way. Alright, if k is not equal to 0, then I wrote this connected function. Basically, this is what it does. I take a default, I create this thing, I create a set called reach. Reach essentially tells me who is connected to, who I can reach within k range. So to do this, the first thing I do is I actually like turning the edges into the reachability, the adjacency matrix. So E is my adjacency matrix version of the edge list. For every edge, I just create the adjacency matrix. I add this guy to the reach. And then I wrap myself to reach. So reach basically will tell me who I can reach. All the other nodes I can reach, including myself. And so this is when k is 1 or more. When k is 1, I stop here. So when k is larger than 1, what I do is then I do for I in range k minus 1. So this is like iteratively adding to the set. For every node in reach, I calculate the destinations. So I take all the guys that I can reach. So for every node in reach, I look at all the people I can currently reach in this range. I find who their neighbors are, who are the neighbors of the people I can reach, and then add them as new destinations to the ones I can reach. Okay, I do this k minus 1 times. Because after I do this, reach will contain all the nodes plus all their neighbors. Yeah, reach will contain the nodes plus all their neighbors. So I do this k minus 1 times. Yeah. If I remove this, I will do it k times. So this is like a slight optimization. So if I do that, this will give me how many this is connected. And so using this function, what I do is first I find reach 1 equals connected edges k. So I find for the first tree, for each node, how many guys you can connect to. And then if k equals to 1 means that I can only connect to one person on the other tree. I don't even have to calculate edges for the other tree. Because I know k equals to 1, I only connect to the first node, right? It doesn't matter what the structure of the tree is. So for I in range blah, results I equals to length of reach 1 I plus 1. So reach 1 tells me which are the nodes I can connect to. And then reach 2 is connected. So same thing, CS time k minus 1. And yeah, I don't actually need this. Yeah, so this part is finding in reach 2 which is the node that has the most connections. So this max, in this particular example, mx will be this node 1 over here. In this example, mx it will be 4. In this particular example. So this is the most well-connected node. So mx is the maximum, most well-connected node. So what I do then is I go again for I in range n, results I equals to length of reach 1 I plus mx. So whoever I am, I find out who I can reach within range k and plus mx. mx is the bonus. So this gives you the correct answer, but somehow I got a TLE. I'm not super sure why. I think it have something to do with like sets or dictionaries that's particular to specific to Java, to Python that I don't quite understand. I'm going to spend some time researching this a little bit because I feel like I don't want to get into this problem again next time. But we'll see how it goes. I have pastebin. Yeah. You have pastebin. Just pastebin. I would love to see what your code is. Or you can actually send, Nash, you can have a link. If you want, you can actually have a link. And you can write a comment on this video actually. You can comment your link to your LeetCode contest solution page. I think you can do that. If you go to the contest screen and you go to like ranking and then you find yourself. Oh, oops. You can actually click on this. Yeah, if you sort of find your own ranking. Yeah, you can actually click on other people. Let me see. Oh wow. Yeah, so if I don't know how to what's the best way to link to this. Yeah, but there should be a way. If you click on this, you get this solution. You can just copy paste it. You put it in pastebin. I'd love to take a look at it. Yeah. Just BFS for 3.1. Yeah, 3.2 for 3.2 nodes. Yeah, so that's what I did too. Yeah. That's so funny. I don't get it. I did the exact same thing as you. I'm also doing BFS. So why is it that I have a TLE? I think it's because I tried getting fancy with the sets. And there's something about Python sets that I'm maybe not understanding very well. I may be duplicating the sets a little bit. Like when I'm updating the sets, maybe I'm creating a new set. Links are not allowed in the chat, just add it. Oh, interesting. Yeah, if you're able to add a comment to the video, actually that would be helpful because then people can see, then more people who watch the video will be able to see your answer, if that's okay with you. Yeah, but I'd love to check it out to see how what you actually did there. Okay, cool. So I think that's the end of the stream. I unfortunately did not do very well this time. I only got 2 questions. Third one, I'm 90% sure is correct. I don't know why I got TLE. I struggled for a long time. I couldn't manage to fix it. I might take a look at it again. You have way better edge case handling than me. There must be a bug in traversal. I think there's a bug in traversal. Yeah. So initially, I didn't have any handling edge case at all. Because I have TLE, I went back, added all the stupid edge cases, and it still didn't work. I think it has to do with the set object creation. That's my guess. It has to do with object creation of Python. Let me see, where is it? I strongly believe it has to do with object creation in Python. yeah, it has to do with object creation somewhere here in Python, where I think I'm creating additional objects for these sets and these dictionary objects. So I think that's what I'm doing. That's one of the shortcomings of Python. They create a lot of random objects for no reason. That's not something that Java or especially C++, they really respect your efficiency. They'll never do that to you. So I might take a look at this more carefully. Yeah, I don't know. Oh well. You live and learn, you live and learn. But thanks a lot. Once again, congrats to Maddox. Congrats to Nash for getting 3 questions. Thanks to everybody for sticking in here. This would be the end of the stream unless people have more questions. If you do, feel free to drop a comment onto the video itself. I would definitely appreciate you liking and subscribing to the channel. Liking the video is going to help me out a lot. It's going to help more people discover my channel, and then you have more people join the stream and chat. And we'll all do LeetCode together every week. Okay, I'm going to sign out here. Thanks a lot for coming. And see you next week for the bi-weekly contest. Yeah, thanks a lot, Maddox. I appreciate that. Bye, folks.